Now that we've studied the properties in the interior metal of the conductor, let's look at what happens on the boundaries of the conductor. So again, we'll draw our conductor. We know that E is 0. And the first thing that we want to imagine is what would happen if we put a plus charge Q on the outside of the conductor. Well, we know that in principle, this charge is producing some fields, and the charge carriers in the conductor will feel an attractive electric force. So what we would expect to see is negative charges on the surface of the conductor, and we would expect these field lines to bend to end on these charges. Now, what's happening is what we have here is something that we'll call an induced surface charge density on this conductor. And what is the result of these free electrons that have moved over here? If this field is producing an electric field that in the interior of the conductor, let's call this E inside, the field on the inside of the conductor, E inside, is equal to, and let's refer to this as an external field. So this is external. So it's equal to the external field, which is just the field of a point charge, plus the field of the induced charges. And inside the metal, these two fields have to add up to 0. And so what's happening is this induced charge distribution is producing exactly the type of field to cancel the plus field on the interior of the conductor. Now, is it just negative charges in this induced charge distribution? Well, that depends on whether the conductor was charged up initially or not. If it were a neutral conductor and charge carriers move to this side, then we would expect on the other side of the conductor to perhaps have positive charges where the field lines are emanating from those positive charges. And there might be points on the surface of the conductor where the field is 0. And so what we can say is that the sigma induced in general is non-uniform. And what it's doing is exactly canceling the external electric field in the metal of the conductor. And this process is something that we refer to as shielding. And that's our first look at what happens to the charges. What's important here is that the free charge carriers are on the boundary on the surface of the conductor.